Let's see if we can use the knowledge we gathered from the first two parts into something practical. First, let's open a new project, and this time I'm going to use a template specifically created by our office. One of the things you can set up in a project or a project template is the landing page. This is going to always be the first view that you see when you open the model. We can see that we have some views created. Let's compare this to what we saw before in the project browser. If I go back to Revit 2023, the sample architecture model, the project browser looks a little different. One thing you can notice here when you work in this new version of Revit is that in the project browser, you'll find checkboxes next to views. If the checkbox is blue, that means that the view is placed somewhere on the sheet. To find out this information in the previous versions of Revit, you need to right-click on a view and see if Open Shade option is active or grayed out. Let's quickly analyze the logic of this project browser. When I click Collapse All in the project browser, I can see the main branches. And for now, let's focus on the first one, views. Here we can see the views are divided in the project browser by type, so floor plans, 3D views, elevations, and so on. When I expand each of this branch, I can open a view of that type in the view area by double-clicking. The way that the project browser looks like can be to a certain extent controlled by the user. When I collapse all again, all these main branches look the same as in the previous file. However, now we have two levels of organizations for views. First one is the same as in the example before, view type. So here we have floor plans, 3D sections. However, there is an additional step to the organization of the views. So only after I expand this branch, I can access the view by double clicking on it. So how do we understand and control the logic of a project browser? What controls it? If I go to View tab on the ribbon, on the far right, there's a user interface drop-down list. And here we have browser organization button, which opens the window where we can control this. Here we can see that we're currently using our company custom organization settings. If I click Edit and go to Grouping and Sorting tab, we can see details. What this means here is that first, our views will be grouped by the value of the parameter family, and then by the value of the parameter UPO underscore sort Q1. Let me remind you here something I said before about Properties window. When we have nothing selected, the Properties window will show the properties of the view itself. Family name you will find here. So floor plan is the value of parameter called family or family name. That was the first parameter controlling how our views are organized, and the second was UPO sort Q1. And the reason I knew I'm gonna find it here is because the view organization can only be controlled by view parameters. When I expand this drop-down list, all these parameters that we see are view parameters. And I can use the values of these parameters to group and sort views. So for example, this view, because the value in this parameter is 01 underscore delivery, that's the value that shows up here in the project browser. If I change this, let me just unlock the view template. Let's see what happens. The name of this branch has changed. The branches are connected with the values of the parameters assigned to control browser organization, and we can only use view parameters to do this. Let me reverse this action. So now let's go to floor plan level 1 FP example plan work in progress, close all inactive views, and let's try to draw a pipe. I'm using a shortcut PI to pull up pipe placing tool. At the beginning, we only have standard generic pipe loaded. This is an element that should be in every Revit model by default. Before I started drawing pipe, let's just take a look at the interface a little bit. So again, just like when we were placing walls, a contextual tab appears. But of course, it is different because we are in the context of a different action. Now it is called modify/place pipe. We have different tools on the ribbon and on the options bar. Here is the diameter of the pipe, and here is middle elevation, minus 100 millimeters. This refers to the reference level of a pipe. So if I'm in this floor plan and I have nothing selected, I can look at my view properties and find a parameter called associated level. Here the value, or so the name of that level is L00. This means that when I draw this pipe, it will be positioned so that its geometrical center will lay exactly 100 millimeters below level L00. Let's draw a pipe segment. This is how it looks on the floor plan. Let's take a look at the 3D. So why does the pipe here looks like it has realistic dimensions, and in the 3D view it looks like just a line? The reason is the detail level. In our view control bar, if I change this to coarse, you can see it would look also like a line. So make sure that your detail level when you draw pipes is always set to fine, unless you're doing a specific drawing where you don't need to see details. Now you can double check the elevation of the pipe. So the middle elevation, this is the middle elevation, and this is the middle elevation. Those are the same parameters. We can change it from here, and you can see it changes at the options bar as well. Also, we have parameters called top elevation and bottom elevation. If this pipe diameter is 20 millimeters and the middle elevation is the central line, then top elevation is the very top of the pipe and bottom elevation is the lowest point of the pipe. Take a look at this section. Another thing to notice in the context of creating pipes in the interface is that when I select the modeled pipe segment, it actually adds two contextual tabs in the ribbon. Here we have another contextual tab called the piping system. Piping system refers to the function that liquid or gas going through that pipe has. Basically, we can have a lot of the same pipe types going through the building, but ones are used for example, tap water, another one is used for heating water supply, another one is used for heating water return, and so on and so on. Pipe type refers to the product and piping system to the function of all connected elements. Let's say that the piping system in this pipe is hydronic return, and let's change the piping system parameter here to supply. At the beginning, you cannot see much of a difference in the drawing when I do that. Let's see what options we have with our piping system. This is the piping system contextual tab, and you can also see that the properties window, when I activate the other contextual tab, shows me the properties of the piping system. One more time, properties of the pipe, and I change the contextual tab, properties of the piping system. Let's click on the Edit Type button in the Properties window to open a window that shows type parameters. I click the Edit button next to the parameter Graphic Overrides. It's a hydronic return system classification, so I will pick an appropriate color. Now all elements where the value of the parameter system type is set as hydronic return will be displayed in the blue color. Let's do it also for the hydronic supply. And you may have noticed that when I change the piping system for one element, that changes apply to all connected elements, pipes and pipe fittings. I press CS, that is a shortcut for create similar, so a tool that lets you create the same family as the selected one. It automatically assigns that piping system to a new connected element. We can see that everything that's connected has that red color, same here. Another thing is that I was using the systems that were already created in the model. However, if you'd like to, you can create your own system by going to Edit Type, clicking Duplicate button. And now I have a new hydronic supply system. As you can see, the thing that hasn't changed is the system classification. System classifications are limited and controlled by Revit. We cannot add more system classifications. We can only add more system types. The system classification is a type parameter where value is limited to a list specifically prepared to cover all expected pipe functions. When you duplicate a piping system, pay attention to system classification, as that's the only parameter that the value you cannot change. Here you can also change fluid temperature, fluid type. However, these parameters are not very important when you have our UFH plugin. And of course, graphic overrides. Now I can apply this newly created piping system to the element in drawing. I can also duplicate piping systems from Project Browser. If I collapse everything, one of the main branches is called Families. So expand Families, here are the names of the categories of elements in Revit. And if I find category piping systems, here are all the piping systems that are currently created and available in the project. If I want to create, for example, a domestic water piping system, I right click, click duplicate, assign a different name, double click on that copy, which opens again the type parameters window, and proceed with the same steps. To sum up, There's a limited amount of system classifications, but there's unlimited amount of piping systems. System classification help Revit to understand the underlying function of the pipe, and piping systems help the designer to organize and control the project. We will mostly focus on pipe types, however. That's where you manage such aspects as materials, sizes, and fittings. So firstly, an important functionality of pipes are routing preferences. So when I create a pipe, I see that when I change directions, it also creates a pipe fitting. For example, here it creates an elbow. If I start the pipe here and create a T shape, it can create a T. If I use a slice tool and slice the pipe, it creates a coupling between two pipe segments. If I change the diameter of one of those pipes, it changes adapter into a reducer, in Revit nomenclature called transition. So how do I know what type of element will appear? When I click on the pipe segment and go to Type Properties, there's a parameter called Routing Preferences. Click on Edit button that opens a window where we can control these pipe fittings. Here I see, depending on the pipe layout, what kind of solution will be chosen by default for this pipe type. So for example, if I change the direction of the pipe segment, it will create this type of elbow. When there is a junction, it creates a T. Then we have a cross, a transition, so an adapter, a union, so a coupling upon our fittings, a flange, and a cap. This is a great example of automation capabilities of BIM. The ones I showed you there are, of course, generic elements, and they don't represent any actual product or any manufacturer. Let me show you how this looks upon our products. Downloading and installing plugin will create its own tab on Ribbon. When you go to Pipe Systems tool, it opens this window. You can pick a market, a language, and whichever types of products that you need. It will load families with parameters that are the actual product data, and the models closely represent products from the catalog. I will just use the country of Finland and English language. I set up my preferences and I click Create System. It will take a moment. When you're using our dynamic library plugin, it will not only load all elements needed for the system, pipe segments and fittings, but will also automatically set these routing preferences for you. Now I can close this window. So now when I use pipe tool, when I expand the type selector, which is the part of the properties window at the very top that allows you to see all the families from specific category in the model, you can see that the system has been created and is available here. I can also find it in the project browser. If I go to pipes category and expand it, this pipe type creates a flexible bands where the pipe changes direction instead of unflexible elbows. When we are using a flexible pipe coil and we want to manipulate the direction of the pipe layout, Revit does not recognize that this element is still a part of the same pipe. Whenever a pipe changes direction, it assumes it's an elbow and puts that element in the category of pipe fittings. But this still belongs to the category pipes. On the drawing, it looks like they are divided, but we have to imagine this is actually one long pipe. Unfortunately, this is just Revit software internal logic, and we cannot change that. But we use some workarounds with our plugin that we'll talk about later. Now let's see what are the routing preferences for this pipe. So here we have our pipe segments. That's the basic straight pipe and the elbow. We have two different elbows. First one represents the flexible band and the second one is Q&E PPSU. If you would like Revit to pick the second one by default, you have to click on this row and move it up by using the icon on the left. So we're changing the routing preferences of this pipe type. When I draw the pipe now, it creates this elbow. Let me change the visual style to wireframe to make it a little better visible. So this is how we tell Revit what pipe fitting to choose based on the pipe layout, by changing these settings in the routing preferences. Let's quickly create the other pipe fittings available for this pipe type. Slice a segment to create a coupling, change diameter to create a reducer. We can also create a T reducer. Changing routing preferences won't affect already modeled elements. Imagine you have already created a significant amount of your design and now you decided that you change your mind and you want to use different routing preferences. To reapply pipe fittings, hover over any element of connected pipes, click Tab to select the whole network. You might need to do it a few times. Clicking Tab allows us to pinpoint element to select when elements are either close to each other or are connected to one another. When the whole pipe network becomes blue, that's your selection preview. click to select it. From the Contextual tab, click on the Reapply Type tool. Let's do this another way around as well. I got a warning that no outer route solution was found. This happens sometimes. For example, here it happened because there's not enough space to model two flexible bends. So let's move these elements a little bit away from each other. That looks correct.